In this episode, we're going to tackle a challenge that sits underneath almost every cloud security mistake, which is that organizations often do not truly know what sensitive data they have or where it lives. Cloud makes it easy to store, copy, share, and transform information, and that speed is great for productivity while quietly creating new places where sensitive content can hide. When defenders talk about protecting data, beginners sometimes picture a single vault-like database, but real environments include spreadsheets, logs, exports, test datasets, backups, and temporary files scattered across many services. The first step to protecting anything is discovering it, because you cannot apply the right controls if you cannot find what needs control. Classification is how you decide what matters most, and reducing unknown data sprawl is how you keep the environment from growing blind spots faster than you can manage them. By the end, you should be able to explain what sensitive data discovery is, why classification is the decision engine behind it, and how disciplined reduction of unknown sprawl lowers both breach impact and operational stress. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful way to define sensitive data is to focus on impact, meaning what could realistically go wrong if the data were exposed, modified, or deleted. Sensitive data includes information that can harm people, harm the business, or create legal and regulatory consequences if mishandled. That can mean customer information, employee records, credentials, proprietary product designs, financial reports, internal security logs, or business contracts. The exact categories differ between organizations, which is why classification is not a generic label you copy from a textbook, but a set of priorities grounded in business reality. Beginners often assume sensitive means secret, but many exposures are damaging even when the data is not glamorous, such as internal system identifiers that help attackers map the environment. Sensitive also does not always mean personal. Intellectual property and operational details can be just as critical. Once you accept that sensitive data is about impact, discovery becomes a mission to locate the highest impact content and confirm where it is being stored, processed, and duplicated. Sensitive data discovery matters in cloud security because misconfigurations and identity abuse become much more dangerous when you do not know what is at stake. If a storage bucket becomes public and you do not know it contains customer records, you may not treat the incident with the urgency it deserves. If a workload has broad read permissions, you may not realize it can reach a dataset that should have been tightly restricted. If a log system collects raw payloads that include secrets, you may unknowingly turn monitoring into a leakage source. Attackers take advantage of this uncertainty by searching for poorly protected repositories and forgotten exports, because those are often the easiest wins. Beginners sometimes think data protection starts with encryption or access policies, but discovery comes first because it tells you where encryption should be strongest and where access policies must be narrowest. When you know what matters and where it lives, every other security decision becomes clearer and less guessy. Classification is the structured act of sorting data into categories that guide protection decisions, and it works best when it is simple enough to be used consistently. A classification scheme might separate data into a few levels, such as public, internal, confidential, and highly restricted, but the labels matter less than the behaviors they trigger. The purpose is to decide how tightly data should be controlled, how long it should be kept, who can access it, and what monitoring should apply. Beginners sometimes think classification is an academic exercise, yet it is really a translation layer between business value and technical controls. If you cannot explain why a dataset is classified as high impact, you will struggle to justify tighter access rules or stronger monitoring when people push back for convenience. Classification should be tied to real outcomes, such as whether exposure would trigger customer notifications, regulatory penalties, or major business disruption. When classification is meaningful, it becomes the language that connects leadership priorities to cloud security configurations. A practical classification approach also depends on knowing the kinds of sensitive data that commonly exist, including personal, financial, and operational categories. Personally identifiable information, PII, is a common class covering data that can identify a person, such as names combined with other identifiers, contact details, or account numbers. Protected health information, PHI, is another class that matters in health contexts, often carrying strict handling requirements. Payment card industry data, PCI, often includes payment card details and related transaction information that must be protected carefully. Even if your organization is not in a regulated industry, similar categories exist, such as authentication secrets, private keys, internal system inventories, and incident investigation artifacts. Beginners sometimes assume classification equals compliance, but classification is broader than compliance because it includes what the business cannot afford to lose even when no law is involved. When you identify your key categories, you can define what high impact looks like for your environment and then begin searching for that data with a clear purpose. Unknown data sprawl happens because data naturally multiplies as teams collaborate, troubleshoot, and build new systems, often without realizing they are creating new sensitive copies. A report is exported to a spreadsheet for analysis. A spreadsheet is emailed. The emailed copy is downloaded. And suddenly the same sensitive dataset exists in multiple places with different access controls. Developers create test datasets, and those datasets quietly persist long after the project, sometimes in less protected environments. Logging systems collect verbose events, and those events unintentionally capture tokens, email addresses, or customer payloads that were never meant to be stored. Backups, snapshots, and replicas are created for resilience, but if they are not tracked, they become shadow repositories. Beginners often picture sprawl as careless behavior, yet sprawl can be the outcome of normal work done quickly without guardrails. Reducing unknown sprawl is not about blaming people. It is about designing processes so copies are intentional, visible, and limited. Discovery is the process of finding where sensitive data exists, and it should be thought of as both an initial mapping exercise and an ongoing habit. The initial step is building an inventory of where data could live, including object storage, databases, file shares, analytics outputs, data lakes, logs, and messaging systems. The ongoing step is watching for new stores, new datasets, and new flows as the environment changes. Beginners sometimes assume discovery is a one-time project, but cloud environments shift too quickly for that to work, and new data stores appear whenever teams launch new services. Discovery also has to account for both structured data, like database tables with clear columns, and unstructured data, like documents, PDFs, and text blobs that may contain sensitive content. Effective discovery combines knowledge of business workflows with technical visibility into storage locations. When discovery is continuous, it becomes much harder for sensitive data to sit unnoticed for months in an exposed location. Metadata is a powerful ally in discovery because it often reveals sensitive patterns without requiring deep inspection of every byte. Object names, folder structures, database schema names, and tags can provide strong clues about what a dataset contains, especially when naming conventions are consistent. Access patterns can also act as hints, because datasets that are accessed by privileged services or limited user groups may be sensitive by nature. Beginners sometimes focus only on content scanning, but content scanning can be resource-intensive, and metadata can help you narrow the search to high-probability locations. The goal is not to rely on metadata alone, because names can be misleading, but to use it as a practical guide that improves efficiency. When you pair metadata clues with knowledge of business processes, you can prioritize where to look first, such as exports folders, audit log repositories, or shared analytics buckets. A mature discovery process treats metadata as an index that makes the problem manageable at scale. Ownership is another essential concept because data that belongs to everyone often ends up protected by no one. In practice, every important dataset should have a clear data owner who understands what the data is, why it exists, and what acceptable use looks like. That owner does not need to be a security expert, but they must be able to answer basic questions about sensitivity, retention, and sharing needs. Beginners sometimes assume security teams classify everything, yet security teams rarely have the business context to decide whether a dataset is mission-critical or merely convenient. Ownership creates accountability, which makes classification decisions defensible and reduces confusion when access requests arise. It also makes cleanup possible, because unknown sprawl is hard to reduce when no one feels responsible for deciding what can be deleted or consolidated. When ownership is clear, discovery findings lead to action rather than debates that never end. Reducing unknown sprawl depends on data minimization, which is the habit of keeping only what you need, keeping it only as long as you need it, and keeping it in as few places as practical. Minimization is not about starving the business of data, but about preventing uncontrolled copying and retention that increases breach impact. If a dataset is sensitive, it should not be casually exported into less controlled storage just to make analysis easier, because that convenience often becomes permanent exposure. Beginners sometimes think more copies equal more safety, as if redundancy always helps, but extra copies also create extra attack surface and extra cleanup work during incidents. Minimization also includes reducing sensitive data in logs and telemetry, because logs are frequently shared broadly and retained for long periods. When you minimize, you shrink the number of places you must secure, monitor, and audit, which makes strong security more realistic and sustainable. A key beginner misunderstanding is believing that classification is only about labeling data, when the real value comes from what you do differently once the classification is known. Classification should drive access choices, such as requiring narrower permissions and stronger approvals for high-impact datasets. It should influence encryption and key decisions, such as using stronger protections for the most sensitive repositories and ensuring key access is tightly scoped. It should inform retention and lifecycle rules, because keeping highly sensitive exports forever is rarely a good idea. It should shape monitoring priorities, because unusual access to a high-impact dataset deserves faster investigation than unusual access to a low-impact public dataset. If classification does not change behavior, it becomes a paperwork exercise that people ignore. When classification changes behavior consistently, it becomes one of the strongest levers you have to reduce real-world cloud risk. Discovery and classification also need to be revisited regularly, because what matters can change, and data can become more sensitive over time depending on context. A dataset that is harmless in isolation can become highly sensitive when combined with another dataset, which is a common risk in analytics environments. Data that was acceptable for a short-term project can become a long-term liability if it is retained beyond its purpose. New regulations, new customers, or new business models can shift which data categories carry higher impact. Beginners sometimes assume sensitivity is fixed, yet sensitivity is often tied to how data is used and what it can reveal. A healthy program treats discovery as ongoing and classification as adjustable, so the organization remains aligned with reality rather than with outdated assumptions. This adaptability reduces the chance that yesterday's low-risk repository becomes tomorrow's breach headline simply because no one updated the rules. When you connect sensitive data discovery to the broader cloud security story, you can see that it is the foundation for nearly every other control we have discussed. Identity monitoring becomes more meaningful when you know which identities can reach the most sensitive datasets. Lateral movement detection becomes higher signal when you know which storage locations represent crown jewels and should rarely be touched by certain workloads. Exfiltration detection becomes more accurate when you know what high-impact data looks like and where it normally flows. Storage controls like safe sharing defaults and versioning become easier to prioritize when you know which buckets and repositories truly matter most. Beginners often want to jump straight to advanced detections, yet the best detections are powered by accurate context about data sensitivity. Discovery and classification provide that context, and reducing sprawl keeps the context from decaying as the environment evolves. To close, discovering sensitive data and reducing unknown data sprawl is the work of turning an environment from a guessing game into a map, where you know what matters, where it lives, and how it should be handled. Classification provides the decision framework that ties business impact to technical controls, while discovery provides the visibility needed to apply those controls to real storage locations and real datasets. Sprawl reduction keeps the problem manageable by limiting uncontrolled copies, discouraging endless retention, and shrinking the number of places attackers can search for easy wins. For a brand new learner, The most important lesson is that data protection is not only about locking down what you already know, but also about finding what you did not realize you had. When you make sensitive data visible, assign ownership, apply meaningful classifications, and aggressively reduce unknown sprawl, you build a cloud environment where security controls can be targeted, consistent, and effective over time.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.